Hello. Welcome to my channel today. We are together with one beautiful proof. Actually, this limit has a very important place in mathematics. To calculate this limit, use the logarithm function. So what do I mean? Let's take one number hand like a divided by 1 plus a. Let's say small ln 1 plus a. It's small too, is it really? For example, let's take a here 2. What will it be? 2, 3 is small. ln 3 is smaller than 3. 2, 3 already, one simple fraction. We will calculate according to the base of ln 3a. That is a small number. What will happen to the friends we call 3? It will be bigger than these. Now on this, if we continue, where we see this as you can see in the question r divided by x, where we see a, let's write r over x. And if our equation turned into r over x over 1 plus r over x, is it small? It happens that way. ln 1 plus r over x is less than, converted to r over x format. Now what will we do next? Of course, in this equality, what is this x value? We get always from scratch. But we know that if we multiply all sides by x, what does this become when x and I multiply this or divided? 1 plus r over x is less than x times natural logarithms. 1 plus r over x is less than, converted to r format. What can we do later? Let's use the logarithm feature. So what do I mean? Here is the logarithm. A above b, what did we know? Here, we knew that b fell to the front as a product. What will happen in this case? This b times the logarithm will turn into a. Then let's bring it here and use it. So what happened? Our expression is r divided. 1 plus r over x is less than natural logarithms 1 plus r over x. It will be x. It came as the top, this one over there. Then if we continue, we can say small is r. Actually, why? We got its natural logarithm. You will understand here. Because what was the problem in the first place? If you pay attention to our question, he gave it as a top. My goal is to go there later on both sides of the equation. So what do I mean? This part of the equation and that part of the equation. Let's calculate the limits. So the limit, x goes forever. Brio divided by 1 plus r divided by x. If you pay attention, let's see the other. Limit x goes to infinity, and this is. Now what will be their limits? Number divided by infinity, what will come from this part? Automatically 0. Then fix it automatically. Where r divided by 1 is the constant, his limit is equal to himself. He came here. Is the same here. The limit of the constant is equal to itself. Look, if you pay attention, they both came here. What do we use here now? From now on, we will use compression theory. So what do I mean? Let's go to the other page. In our hands. So what is this compression theory if you say 1fx? Here is less is equal to gx. Small is equal. For example, there are 3 functions called hx. If I want to draw them like this, here x, here y. This is the origin. Let this point be the place we call a. I'll look at their limits in a. Of course, it would be sweeter if we wrote the first head statement. Limit x going to a fx function is equal to limit x going to a hx function is equal. If both have limits, then the limit x on the way to a. What should be the limit of gx? L must be So how will it be if we want to draw them, for example? Look at the limits at this point. Let's assume that this is light. Let's make each one in a different color. Let's give an example now. One can come from below. It can go like this. Let's call it 4. What could one be? May come like this. May come like this. It can go like this. One of them came from the top like this. Like this again. Of course, a little worse. This shape can go. What should we say to that? Let's say function a. At this point, they all have limits. What are we doing in our compression theory? We can say, so what will we do next? Let's say limit x goes forever. Natural logarithms. 1 plus r over x. Over x. Let's say equal. We can say that now. Because they're limits. What did we find on the previous page that it was r? What did we do automatically if you pay attention? The limits of these we said that this expression is also r. If we continue now, how else can I write this? Limit x goes to infinity. Natural logarithms. 1 plus r over x above x. What can we do with x from the property of this limit? We can throw this hand out. What will be, Ellen? Limit x goes forever. 1 plus r over x to the x expression we call. This is what we know, the part we use constantly. Limit x goes to infinity. 1 plus 1 over x to the x is equal to n. E to the r will be transformed. So what was the part we were trying to get here? Let's give an example of this right away. Let's take r to 1. What will happen if we take r to 1? Limit x goes forever. 1 plus 1 over x above. Let's say x. Yes. Of course I didn't write this wrong, did I? There will be r, yes, I think there should be r. Well, let's pay attention here. I can tell you what it is. I can say it's e. Where did we say, look about me? We bought the r here completely, we bought one time. We found the result. Yes, here is what is very important for mathematicians. Also very important for those interested in Mathematics 1. We proved the theory. I hope it was useful. Please don't forget to like and follow my channel. See you in the next videos. Bye-bye.
Ladies and gentlemen,